Welcome back to the channel. So today, before we start our video, I just wanted to say thank you so much everybody for the support over the last 1 year for my channel. I'm so grateful that we passed 100,000 subscribers. So to whoever's watching, thank you so much for everything. And this couldn't have been possible without anyone who's watching these videos. So thank you so much, and this is my first video after crossing the 100K mark. And yeah, so let's dive into this problem without any further ado. So here we're given a function, and so this is a piecewise function, and we're asked, is it continuous at x equals 3? So firstly, what does continuous mean? Well, that just means when you're drawing a function or like a graph, right? If it's continuous, you shouldn't have to pick up your pencil anywhere when you're drawing it. So if it's continuous, if you don't have to pick up your pencil, if you have to like maybe pick up your pencil, so like maybe like let's say your function looks like this, and there's a hole here, and then the point's actually here, right? I have to pick up my pencil, right? So that's gonna be a discontinuous graph, right? But if it's something like let's say a sine function, right? I don't have to pick up my pencil and just keep going, right? So that means that it's continuous. So now let's look at what this problem is asking. So it's asking f of x, is it continuous at x equals 3? So when x equals 3. So the criteria for a graph being continuous or not, looking at it algebraically, analytically, is that f of x should exist, right? The limit as x approaches whatever value, right? F of x approaches c of f of c, that also should exist. And the last criteria is that these two values are equal to each other. So they should be the same here. So yeah, so as x approaches c. Yeah, so that means that both of those values have to be the same, and they both have to exist. And that's it. That's all there is to continue in discontinuity. So if we look at this problem, when x is equal to 3 directly, we have 5, right? So that means that f of x already, we can say that does exist, right? Now we have to look at the limit where x is not equal to 3, but we want to look at what's happening as it's approaching 3. So we can't, as you can see, we can't substitute in 3 here, right? Because then the bottom is going to be 0, and then it's going to be undefined. So for that, we're going to just have to factor. So if we write this, right, lim as x approaches 3, x squared minus x minus 6 over x minus 3, right? This just factors to x minus 3x plus 2, right? Then the x minus 3 here and x minus 3 here can cancel, right? So all you have left is just lim as x approaches 3 of x plus 2, right? So what do we have now when we put in 3? Well, we get 5 here, right? So the limit as x approaches 3 for this function, for this part of the function, is 5, right? So that means that the limit here exists, and then the limit here also we found that exists, right? And they're both the same. So that means that this graph is continuous. Yes, f of x is continuous at x equals 3. Yeah, that's all there is to this problem. So I hope you learned something. I hope you understood this concept, and I'll see you in the next one. Thank you.